Okay, I'm going to record the review for you. Question 1 says, label as translucent, transparent, or opaque the following object. So, a window is transparent because all the light comes through it without any distortion. A frosted bulb, light bulb actually, is translucent. Frosting keeps it from being transparent. Letter C says a neon sign. The key says translucent, but I don't know. I think I would take transparent also because it's usually a clear glass tube that the gas has been pumped into. It might be colored, but you can still see through it. A wall is opaque, obviously. You can't see what's behind it. And then letter E asks about a convex lens, and that's the lenses we use in lab. The one that gave you the upside down candle flame, and it is transparent. Okay, the second question says explain how a rainbow is formed. Well, a rainbow comes from refraction, which is the bending of light as it passes through the water droplet, and total internal reflection. R-E-F-L-E-C-C-I-O-N in a water droplet. Gives us that rainbow look. Letter number 3 says the focal length of a lens depends on what two things. The index of refraction is the first thing. What is the lens made of? And then the second thing is the shape of the lens. Is it convex? Is it concave? Is it both? So I need to know the shape of the lens. All right. Let's go to a blue here. All right. So the fourth one says, identify which are electromagnetic waves. Those are waves that travel at 3 times 10 to the 8 meters per second, which is the speed of light. And there are 4 of them. So letter B is a electromagnetic wave. Letter D is in dog. Letter E, X-rays. And letter D, gamma rays are all electromagnetic. They're part of the electromagnetic spectrum. Okay, number 5. Number 5 says which color of light carries the most energy. So violet carries the most. Shortest wavelength, highest frequency. And red carries the least. Okay, number 6. Let's change colors. Number 6. Okay, number 6 says which color of light travels with the highest frequency. Well, I just said it in the one above, but violet has the highest frequency. That's why it has the most energy. It's vibrating very fast. And red has the least amount of frequency. All right, number 7 says which color of light is bent the most. So violet is refracted the most, or bent the most. And red is the least bent. We'll stop now. They're going to come on the PA. Okay, question 8.
Just a quick reminder to our students.
Speed of light in the air is 3 times 10 to the 8.
Of course, reminder to our students, you have to pass the state mandated assessment for graduation purposes. So some concentrated said, take your time, put forth your best effort, and utilize the information that teachers
Okay, so I've answered those without talking because Mr. Martindale is making an announcement, but what I know is this is the 3 times 10 to the 8. That's the speed of light in air. And B is the speed of light in the substance. Whatever the substance is, glass, water, doesn't matter. Okay, that takes care of number 9. Okay, number 10 says, use the following characteristics of lenses to answer the next 2 questions. You'll see something like this on the test, and I've given you 8 characteristics, and I want you to fill in the blank with the numbers that represent the correct characteristics. So the image of an object located at twice the focal length of a converging lens. Well, here's a converging lens, and if this is F, 2F, and this is F and 2F, and I'm trying to make them the same distance, but I don't have a ruler, so it's kind of sketchy. So there's my object. My image is going to be right here. It's going to be the same size as the object. It's inverted. It's real. And it's OSOL, opposite side of the lens. So I'm going to pick number 1, that it's real, number 4, that it's inverted, and number 6, that it's the same size. All right. Number 11. Number 11 is an image that's described for us, and that image is a real object that, I'm looking for the image of a real object that is formed by a diverging lens. Well, a diverging lens is this. It only has one case. It always makes it smaller, makes it virtual, and makes it upright. So that's going to be numbers 2, 3, and 5. All right. Number 12. Number 12 says the image of an object located at the focal point is, and number 8 is the correct answer there, which means none of the above because it's non-existent. If the object is at F, there is no image. Okay, number 13. The image of an object located inside the focal length of a convex lens. So here's my focal length. Here's my object. So it goes in and straight through, and it goes through the center of the lens. And these rays get farther and farther apart, have the forces to intersect. So there's my object. So my object is virtual, or image I should say, is virtual, it's upright, and it is magnified or larger. And so those numbers for the answer on number 13 are numbers 2, 3, and 7. Okay? We'll do 14, and then we're going to save it and get on with a new recording. It says on 14, as a beam of light travels from one medium to the next, the light ray is refracted or bent. How do you know which way the light ray bends in the relationship to the normal? Okay, so if it goes from a more dense to less dense, it goes away from the normal. So here's my normal. This is glass. This is air. So it comes in something, come in. I do a little better. Comes like that, and I'd say that angle is 33. When it gets out into the air, it's going to go something like that. So let's say that angle is 65. Okay? Then if it goes from less dense to more dense, it's going to bend towards the normal. So if it goes from more less dense, so let's say that's going from air to glass. I'm going to make this be, it's coming in, I'm not doing a very good job, 55 degrees, let's say. And this will be something like that, and it's 38. It'll be smaller. Okay.